Hello. Today I am going to show a demo of natural language querying over the databases. The demo is on the finance ontology derived from FIBO and transaction processing TPOCS benchmarks. On the home page of the demo, you see several pre-populated queries that are answerable over the finance domain. Let's have a look at the finance ontology. This part of the ontology is derived from FIBO. It has financial metrics reported according to the FIBO standards. This part of the ontology is derived from TPOCS benchmark. It has details of holdings, securities and their transactions. This part of the ontology connects the FIBO and TPOCS components. It has details about customers, corporations, and industries and how they relate to FIBO and TPOCS. Let's start querying this ontology. We start with simple queries and then look into more complex ones. This query asked for the address of account holders in California. We see that in the response. Next, we ask a numerical count query about account managers with more than 1,000 accounts. The response shows a bar chart showing account managers and their counts. Let's find out who are the most active account holders based on the number of transactions. To get this information, with this tool, all we need to do is ask for it. Clicking on this option shows the SQL query that was fired to get the response from the underlying database. Next, we ask complex queries that involves detailed reasoning. Let's find out the transactions that are made at prices lower than the average selling price. To get to the answer, first NLQ needs to find average selling price and then compare each transaction against this. If we look at the SQL query, we see there is an inner query that computes the average first, and then each transaction is compared against that average. Next, we try a more complex query where we want to find out earlier stock purchases which have now increased in value. Let's try this question. As you can see, this question is asking for stock purchases that have gone up in value. The comparison is between the current value and the purchase time value computed through a nested query. This inner query computes the current stock price. The query is specifically asking only for the second quarter 2016 purchases. As you can see from the generated SQL query, the system could recognize the precise time phrase and put a corresponding time filter only on the outer query, i.e. the purchase time, and not on the current stock price. The UI is interactive, where a user can simply type queries in the search box. Let's see an example. I am trying to find those stocks which were sold earlier, and now the stock price has fell down. I'm actually using a mathematical operation in percentage, say decreased by 50%. These are the stocks and their purchase value as you can see in the screen. As you can see from the generated SQL query, the system interprets 50% decrease and correspondingly does our multiplication with 0.5 before comparing against the inner query result. As you can see, the system can handle a wide range of business intelligence queries, which includes complex nesting types also. We demonstrated using an interactive UI, where users are free to try their own queries as well. Thank you for watching the demo.